All right, let's get started with the probability unit test in the statistics portion. So, for the first question, they are asking us to find the two-way table below displays demographic data for the passengers aboard the Titanic. So, okay, we have given a data with first class, second, third, and total man, woman, child, and total. Okay. Given that a passenger selected random was a child, find the probability that the passenger traveled in the third class. So this is a conditional probability, and we know the formula for finding conditional probability is, this thing would equal the probability of third class, the probability of third class, and child over the probability of child. Now, what is the probability that the passenger is traveling both third class and child? So we look at this row here and this column here. The intersection is the data or the value that we are interested, so which is 79. So the probability that the passenger is third class and is also a child, which is 79 upon the total number of passengers, not this total, the entire total, which is 1316. This is the probability for third class and child. Now we are done with this. We want to divide that with the probability of child, which is the total probability here. I mean, the total number of child, which is 109. So 109 divided by the total passenger 1316. So if you multiply that, 79 over 1316 multiplied by 1316 upon 709, because we're changing the sign from division to multiplication, the fraction gets reciprocal, so these things gets cancel out. We have 79 over 109. So let's see whether that can be simplified more as well or not. Okay, so it doesn't. So our final answer is 79 over 109. 79 over 109. Okay, let's check. There you go. For the second question, a saloon owner noted what types of services its clients request last week. Here are the results: dye, haircut, and permanent. Okay, 15% represents the number or percentage of owners who request none of these three: dye, haircut, and permanent. In this sample, are the events dye and permanent mutually exclusive? So mutually exclusive refers to the incident where if you have one, you cannot have the another. So which means if you have dye, you cannot have permanent. So which is in accordance with this. It shows that there isn't any intersection between the Venn diagram dye and the Venn diagram permanent. As you can see, if there was an intersection, it would have been like this, okay, with an intersection, but it is completely different with no intersection. So which means they are mutually exclusive. If you have dye, you can't have permanent. If you have permanent, you can't have dye. So I'll select yes for the first question. Then we are finding the probability that a randomly selected person from this sample requested a dye or a permanent. So total is 100%, we know, and they have given us the amount in the numbers in percentage, um, which is um, already some work done, and it's easy for us to find. We just have to remove the percentage sign, and that is our probability. Dye or permanent. So we have a total 35% who selected dye, so 35. Or if you have or, we add the probabilities, and if it is and, then we multiply. So or permanent, which is this figure here, which is 15. So we have 50% people. So 50% means zero point 0.5 probability. So I'll select zero point 0.5. There we go. For the third question, Mr. Bay prepares a list of 43 US presidents, 8 of whom died in office. Then 18 of his students each select a president. So 18 of the students of Mr. Bay will select a president at random. There can be repeats for their creative writing assignments. What is the probability that at least one of the students select a president who died in the office? So here, this concept or this question resembles that of um, binomial distribution, where you have an experiment, which you have a success. We represent that with x, and here our success is selecting a president who died in the office. Okay, so p, we use the letter p to denote the probability of success and q to denote the probability of failure. And the binomial formula for finding is ncr p to the power r q to the power n minus r. So eight of whom died in the office. In total, we have 43. So 8 upon 43 is the probability that if we choose anyone randomly, that president, died in office. So 8 upon 43. Okay, we want to take as an exact value as possible. So this is the p, and q will be because the summation of probability is 1 minus 8 divided by 43, which is 35 upon 43. So q will be 35 upon 43, the probability of failure. So what is the probability that at least one of them, which means you have to include 1 and 2 and all the up until 18 of his students will select a president random. There can be repeats, which means the probability will stay constant for success and failure. So we're trying to find the probability of x is at least so greater than or equal to 1. Okay, now here's the problem. This is a lengthy process because we have to include both x equals to 1, x equals to 2, x equals to 3. Okay, this can continue until until x equals to 8, because in total you have 8 presidents who died in office, so it cannot go beyond that. However, it is a lengthy process. Instead of finding each of that, what we are interested to use the not the shortcut but smarter way, which means subtracting the probability of x equals to 0 from 1. Okay, so probability of x is greater than equals to 1 includes everything except for 0, so that's why we subtract the probability of x equals to 0 from 1, which is the total probability. So 1 minus ncr. So n is total number of repeats, which is 18, and we select 0, so that becomes 1 anyway. So 1, it's it's equal whether you write or not, so I decide not to. And then you have p to the power r. Again, because r is 0, that is anything with the power 0 is 1, but you have q to the power n minus r, which means our q is here 35 divided by 43, this raised to r. So our r is 8. Okay, so there can be repeats, so it's 18 because there can be repeats. So 1 minus we have 35 upon 43, 35 upon 43 to the power 18. Sorry, not 182, it's 18. Okay, 0. Okay, so round your answer to the nearest hundredth. So this is the ones, okay, nearest hundred. So this is the decimal place. This is ones, tens. Similarly, this is ones, this is tens, this is hundred. We need two decimal places. So if we round that to so 0.98, because the third decimal place is 5. So 0.98 should be our answer. Let's see. 0.98. There we go. All right, for the third question. Rosalind is a teacher who plays a review game with her class. The game involves writing each student's name on an identical slip of paper and selecting students at random. Here's the makeup of her class. So, grade, we have 7 students studying at grade 10, 18 at 11, 5 and 12. Okay. Suppose that Rosalind wants two different students, so she picks two names without replacing names between picks. What is the probability that both students selected are 11th grader? Round your answer to two decimal places. All right. So um, we have a total of 17, 18 plus 7 plus 5. So this is 13 plus 18, which is 31. Okay. 7, we have 7 plus 18, 7 plus 18 plus 5, which is 30 students. Yeah. 7, oh, 7 plus 5 is 12, plus 18, 30 students. So he's a teacher who plays a review game with her class. The game involves writing each student's name on an identical slip of paper. So here's this paper, you write the name, and selecting students at random. So he wants two different students, so she picks two names without replacing names between picks, which means once one you take this, that's it. Uh, you're not putting it back again in the in the place from where you pick up the paper without replacing. So which means for the first time, the probability that you select an 11th grader is 18 upon 30, because there are a number of students, but because you are doing without replacement, the total number decreased by 129, and we're trying to find the probability that both students are 11th graders. So first, if you pick up an 11th grader, that also gets reduced by 1. So this should be our probability. 18 by 30. 18 by 30 multiplied by, we have 17 upon 29. So 0.35 should be our answer. Two decimal places. 0.35. Yep. All right. The probability that Rahul succeeds at any given free throw is 70%. So 70% is 0.7 probability. He was curious how many free throws he can expect to succeed in a sample of 15 free throws. Okay. He simulated 30 samples of 15 free throws, where each free throw had a 0 point probability of being successful. Rahul counted how many free throws were successful in each simulated sample. Here are his results. Use his results to estimate the probability that he succeeds at 11 or fewer free throws in a sample of 15 free throws. So, okay. So we want 11 or fewer, right? So we are including 11 or fewer. But here's the problem. We are not given the data for free throws before 10. So what we do is, because we want 11 at 11 or fewer, we subtract the remaining things, the remaining ones. Okay, these one from 1. So 1 minus, how many 1 do you have? 1, 2, 3, 4, 5. Oops. 1, 2, 3, 4, 5, 6, 7. Okay, so 7, 4, 7, then we have 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Okay, 26. So 1, 2, 3, 4, 5, 6, 7, 8, 16, 17, 18, 19, 20, 21, 22, 23, 24. Wait. 1, 2, 3, 4, 5, 6, 7, 8. So 8 plus 8 is 16. 8 plus 8 is 16, right? Yeah. So 17, 18, 19, 20, 21, 22, 23, 24. Okay, so 24. But why it was 26 in the first time? 1, 2, 3, 4, 5, 6. Oh, this was 6. That's 1, 3. That's the reason. Anyway, so we are trying to find probability 11 or fewer success. In total, we have 30 samples like this. So 1 minus 24 by 30 should be our answer. 1 minus 24 by 30 is 0.2. So our answer should be 0.2. Yep. All right. Dennis examined the records of the clients at his gym and he found these statistics. Probability joined in February, probability member for over 6 months, probability over 6 months, and January. All right. Now we're trying to find the probability that a client remained a member for more than 6 months. So we want this probability more than 6 months, over 6 months, given that the client joined in. Okay, same conditional probability. We know that the probability over 6 months, given that it is January, is equal to probability of over 6 months and January, which is this thing, 0.024, divided by probability in joined in January, which is 0.12, and that is our answer. 0.024 0.024 divided by, we have 0.12. 0.12. So 0.2 is our answer. Let's see. Yep. All right. Tariq and Lucia are finalists in a baking competition. For the final round, each of them will randomly select a card without replacement that will reveal what their primary flavor must be. Here are the available cards. Chocolate. Okay, so we have 6 cards. Tariq wants to get lemon, and Lucia wants to get coffee. Tariq will draw first, followed by Lucia. What is the probability that both contestants get the ingredient they want? Okay, so what is the probability that you have a coffee? Oh no, the lemon, because Tariq will draw first. Okay, so Tariq wants lemon. So we have 6 items in total. So the probability of a lemon is 1 upon 6. Okay, Tariq will draw first, followed by Lucia. What is the probability that both contestants get the ingredient they want? And we need the probability of coffee, which is also 1 upon 6. So because both of them, you know, we want both of them to happen. So once, it is once Tariq takes out coffee, sorry, lemon, we have total decrease by 1, so it becomes 5, and we have 1 coffee, so 1. This is the probability that both contestants get the ingredient they want. 1 upon 6 into 1 upon 5, so 1 upon 30. Okay, 1 upon 30. Oh, we need to round to 2 decimal places, so 1 upon 6 into 1 upon 5, 0.03, 2 decimal places, right? 0.03. Yeah. All right, a website offers a coupon to 50% of its visitors selected at random. So the probability that you get a coupon is 50%, which means zero point 0.5, selected at random each day. Yasemin visits the website for 4 days. What is the probability that Yasemin will not be offered a coupon? So the probability for getting a coupon and not being a coupon is the same. So what is the probability that Yasmin will not be offered a coupon on any given day is zero point 0.5, but on at least one of the days she visits. So at least one means probability of x representing the success. At least one means greater than equals to 1. What is the probability that Yasmin will not be offered a coupon on at least one of the days she visits the website? Round your answer to the nearest hundred, so two decimal places to DP. Probably at least one day without coupon is x equals to 1, x equals to 2, x equals to 3, x equals to 4. A lot of work. We subtract 1 minus probability of x equals to 0. So 1 minus, so 0.5 to the power 4. 1 minus 0.5 to the power 4. We have 0.2 significant, so 0.94. 0.94. Let's see. All right. Ninth question. We have Kylie read a report that said the probability that a randomly selected American is left-handed is 14%, which means 0.14. She was curious how many left-handed students to expect in a class of 25 students. She simulated 40 classes of 25 students where each student selected had a 0.14 probability of being left-handed. Kylie counted how many left-handed students were in each simulated class. Here are her results. Okay, number of left-hand students in a particular class. So it was 2. We have 1, 2, 3, 4, 5, 6, 7. Okay. Number of students, left-hand students. So these dots would add up to 40. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. Yes. So 40 classes. Use our results to estimate the probability that there are fewer than 3 left-handed students in a class. So fewer than is less than 3, which means you're not including 3. You're only considering these portion, which we have total 8 number of classes. What is the probability that there are fewer than 3 left-handed students in a class of 25 students? Okay, so okay, give your answer as either a fraction or a decimal. Probability fewer than 3 left-handed. So we have total 8. Okay, so we have 8 upon the total, which is 40. But here's the question, what do we do with 0.14, which is probability of being left-handed, a randomly selected American? And she used that to find these data in the 40 classes, right? So we don't need that actually, I think. 8 by 40 is 0.2. Exactly. We don't need that. 0.2. So a business owner noted the features of the 100 cars parked at the business. Here are the results. In this sample, are the events 2 doors and 4 doors mutually exclusive? Which means if you have 2 doors, you cannot have 4 doors, which is not, because we can see an intersection. So I'll select no. What is the probability that a random selected car from the sample had 2 doors or 4 doors? Okay, so 2 doors. First find 2 doors. So if you want 2 doors, right, we want to erase in order to see the numbers here. Oh, it's 0. Oh, it's 0. Wow, that's interesting. So 2 doors and 4 doors mutually exclusive, which means if you have 2, you can't have 4. Yeah, they are mutually exclusive. It's a tricky one though. Right, you know, writing zero. Oh, okay. But like, what's the point in writing? Okay, to include the sunroof thing, because you have intersection of sunroof and two doors and sunroof and four doors, you have to use this notation. I get it. All right, so mutually exclusive means you cannot have any intersection, which is the case if you have two doors. See, there isn't any data that represents that having both two doors and four doors. There isn't. This is four doors and sunroof. This is only four doors, two doors, four doors and sunroof. You have zero. So what is the probability two doors is, total you have 100. So all of these data add up to 100. Um, so we have 18 plus 14 for two doors, so which is 32, I guess. 18 plus 14, 32. And for four doors, we have 25 plus 20, which is 45. So 32 plus 45 is 77. 32 plus 45 is 77. Yep. So what is the probability that random symmetric car had two doors or four doors? We have to add because it's or. So we have 77 divided by the total, which is 100, 0.77. So 0.77 is the answer. There you go. And this is